Welcome to my YouTube channel, Maths with Ease by Mr. Gamotho. And in this video, I want us to understand the three steps of differentiation. If we have an equation of a curve in general, and I want to bring a general picture, the three steps here, we have an equation of a curve which could be written in terms of y is equals to kx raised to power n. Obviously, a curve is not a straight line, so n is not equals to 1. It is something greater than 1, so that it can qualify to be a curve. Now, I would want to outline three steps. Step number 1, the original index becomes a coefficient. That is step number 1. The original index becomes a what? A coefficient. Coefficient is a number that multiplies out the function. For example, if n now becomes a coefficient, it is going to have, we are going to have nk x squared. That is now, if you want now to get the gradient of the curve, we have to first of all understand that step. Step number 2, the new index is reduced by 1. The new index is reduced by 1. You reduce it by 1. We are going to see how. And of course, step number 3, we may want to say, though it is already incorporated in the step number 2, we can talk about all constants. All constants die, and I will show you how they die. Now, I want us to take a general equation, or rather, I want us to refer to the table that is just above this explanation in the same slide. And we have the first function is y is equals to x raised to power 1. If we follow the first step, in an attempt to find the gradient, which is the change in y over the change in x now, the original index becomes a coefficient. The original index is 1. So 1 becomes a coefficient, and we have 1x. Then step number 2, the new index is reduced by 1. The original index was 1. That reduced by 1 becomes 0. And therefore, this new index is 0. And that is why we have any number raised to power 0 is a 1. And therefore, the final gradient of such a function, which is a straight line, is actually equals to 1 times 1, which is 1. If we take another function, y is equals to x squared, like the one we explained in the first principle, in the first video of this topic, the change in y over the change in x, which is now the gradient, the original index becomes a coefficient, so 2 times x, and in the same breath, the new index is reduced by 1. That means 2 minus 1 is 1, and therefore, the final gradient dy dx is equals to x raised to power 1, which is 2x. And if you remember, that is actually the gradient we found in the first video. If we take another example, y is equals to x cubed, the dy dx of this, or the change in y over the change in x, which also means the rise of a run, is that the original index becomes a coefficient, so 3x, and the new index now is reduced by 1, meaning 3 minus 1 is 2. And finally, the gradient of a curve at a particular point, this curve becomes 3x squared. I want us to take a general case like it is here. Y is equals to kx raised to power n. The change in y over the change in x, which is the gradient, becomes now, n becomes a coefficient, so n multiplied by k. There is still x, but now the new power is reduced by 1, meaning n minus 1. And because we don't know the value of n minus 1. I have said all constants die. We have not shown that example here. I would want to be deliberate in this, and I want to give ourselves a different example whereby y is equals to probably 2x squared plus 3, whereby we have a constant here. The change in y over the change in x, which is the gradient, and we have to deal with each term at a time. 2 times 2, which is 4x, 2 minus 1 is 1. So we leave it that way. If this is a constant, as you can see, and I would want to explain it here, a constant is in obviously having x, but that x is always raised to power 0, because 3 times 1 remains 3. Now, if we want to take the dy dx of this, the original power or index becomes a coefficient, and we obviously have 0 times 3, which is 0, times anything else, it will remain 0. And that is how all constants die. So our gradient in this particular case remains that plus 0, which is of no use. Even if you say plus 0, then the gradient is always 4x. And that is just how all constants die, due to the fact that they originally inhibited power 0. And that is how they all die. Thank you, and let us meet in the next video.